All right, one more multiplication problem and one more tool to develop visualization of what it means to multiply fractions. So, Chase walks down Old Shakopee Road. Each block is a quarter of a mile. Chase stops walking after 2/3 of a block. How far did he walk? I'm emphasizing because once again, you've got to keep track of the referent. What are we referring to with each of these fractions? First of all, each block is a quarter of a mile. So imagine a mile cut up into fourths, cut up into 4 equal parts. Each part would be a 1/4. But then Chase stops walking after 2/3 of a block, 2/3 of a fourth of a mile. How far did he walk? Well, he walked 2/3 of a block, is what you could say. But I think the spirit of the question here is how far did he walk in miles? So if you would please make a number line like this. This is 1 mile, showing 1 mile, and see if you can think through cutting things up and visualizing what 2/3 of a 1/4 of a mile would look like, and then how many miles would that be? Pause the video, give it a shot first. All right, I'm going to give it a shot. It would look like this. So first of all, I'm going to cut it right in half. I hope that's half. And then I'm going to cut it up into 4 equal parts. Each part would represent 1/4 of a mile. So each block, so here's a block, here's a block, here's a block, here's a block, here's a block. There'd be 4 blocks in a mile since each block is a fourth of a mile. But Chase stops walking after 2/3 of a block. So now I need to take a block and cut it up into thirds. Let's see if I can get this pretty close to thirds. So this is 1/3 of a block, and this is 2/3 of a block, and then this is a full block. So these are referencing the block, where this is referencing the whole mile, this fourth, fourth, fourth. Okay? So what I'm talking about here is Chase stops walking after 2/3 of a block. So Chase walked to here. Now, how far did he walk? He walked 2/3 of a block. But how far did he walk in terms of miles? Can you imagine continuing to cut up these blocks into thirds? So there's another, and there's another. So there would be 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3, 9/3, 10/3, 11/3, 12/3 in terms of blocks. But we want this in terms of miles. And so I cut this up into one. Let me use my mouse so you can see it. I cut this up into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. So the full mile would have 12 of these 1/3. Now Chase stopped walking after 2 of those, and so he stopped walking after 2/3 of a block, which is 2/12 of a mile. Do you see it? So this is another one of those things where you could say that 2/12 is equal to 2/3. What? That doesn't make sense. Well, you gotta have the referent. 2/12 of a full mile, when I'm referencing this whole mile, is equal to 2/3 of a block when I'm referencing just a block. It's the same 2/3 or 2/12. 2/12, 2/3, depending on what the reference is. Now, it's also 2/12. 2/12 is also 1/6 of a mile. Now, how do you see it in terms of 1/6? I'm going to clean up my drawing and come back and show you how you can see it as 1/6. All right, got a little messy there. I want to clean it up. So first of all, remember we cut this thing up into fourths. Hold on, lost my pen. Here we go. So first I cut it up into fourths of a mile, and then we cut each of those up into thirds. The last one was pretty bad. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there were, each one of those is a 1/12 of a mile. But now, can you imagine? Let me change colors. Remember, Chase walked to here. So now imagine grouping these into groups of 2. Hang with me, hang with me. There would be 1, 2, 3, 4, 5, 6. So if I broke up into 1/6 of a miles, that 2/3 of a block, or 2/12 of a mile, is also 1/6 of a mile in blue. So you can see it equivalently depending on how you cut up the mile into 12ths or into 6ths. All right, so a number line can also be a valuable tool, and we can see the algorithm as well. So what I said is 2/3 of a mile, 2/3 of a block, and a block is 1/4 of a mile. So I needed to figure out 2/3 of 1/4, and so 2 times 1, the algorithm, the efficient algorithm is 2 times 1 is 2. Why did that work? Because notice I had 1, 2. I had 2 copies of 1, you could say. And then 3 times 4, that was the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That was the whole mile cut up into 12ths. And so the algorithm can be visually seen, and students can get to the algorithm through their thinking, as opposed to having to start with the algorithm and then you just mimic it. Students will develop the algorithm and make sense of it.